Hello. Today we are going to go over Note 6.6, Solving Radical Equations. A radical equation is an equation that has a variable in the radicand or a variable with a rational exponent. Remember, the radicand is what is underneath the radical. So for example, the 2 is a radicand. Right? Okay, so how do we solve the square root of 4x plus 1 minus 5? Well, what if we squared the square root of 2? What would happen? The square root and the square root would be reduced, and you would just get 2. So you're going to use the inverse operation. Well, for square root, it would be squaring. So if you added 5 to both sides, right, you would be here. Now if you square both sides, right, on the right, that's going to be easy. That's just 25. But on the left, what happens is the square root and the square inverse operation, so it's like they reduce, and all you have is 4x plus 1. So now it's just a linear equation. So I'm going to subtract 1 from both sides, and then I'm going to divide by 4. So then I get x equals 6. Okay, so if you're looking at example 1, what I want to do is I want to isolate that radical. Because what I want to do is get everything on one side and the radical on the other, so I can square both sides to get rid of it. So I'm going to subtract 2 from both sides. Then now I can square both sides. And I get x plus 5 on the left and 4 on the right. So subtract 5 and I get negative 1. Okay, well, what if you had something like the example here, x plus 3 to the 2/3 equals 4. So if I could get rid of the 2/3, right, I would be in good shape. So how can I get rid of the 2/3? Well, if I can make that 2/3 a 1, right, then I'd be good. I wouldn't have to have anything. I would just have x plus 3. So how do I make 2/3 into 1? Well, we're going to use multiplication. We're going to raise this to 3 over 2. So why 3 over 2? Well, what happens when you have a power raised to a power? You multiply. So what's going to end up happening is you end up getting 6 over 6, so you get 1. So this becomes x plus 3 to the 1, right, which we would write as just x plus 3. So by raising it to its reciprocal, you end up making it to the power of 1, so then you can get rid of the grouping symbols. Well, what you do to one side of the equation, you must do to the other. So I also have to raise 4 to the 3/2. So 4 to the 3/2, well, right, remember earlier in the unit, that's telling you to take the square root of 4 3 times. Right? Because the denominator is the root you take. The numerator is how many times you take the root. Now, you have to be careful because you're taking the square root and we're solving an equation here. This is actually going to be plus or minus 2 to the 3rd power because the square root of 4 is 2. Remember, when you're solving equations, you're looking for all possible solutions. So it could be plus 2 or negative 2. So this ends up becoming x plus 3 equals plus or minus 8, because 2 cubed is 8. So if you come over here, you can subtract the 3. So it's 3 plus or minus 8. So x equals 3 plus 8, which is 11. And then x equals 3 minus 8, which is negative 5. So you end up getting 2 solutions. But again, that all comes from the fact that I have to take the square root and I'm solving an equation. So whenever you're solving equations that look like x to the m over n, you're just going to raise the equation to the reciprocal, which would be n over n. You just take your fraction and you flip it. That's what reciprocal means. So example 2 doesn't look like that. It's just not x to some power equals k. So I'm going to divide both sides by 5 first. So I have 3x plus 1 to the 1/4 equals 2. So now to get rid of the 1/4, right, I'm going to raise it to the 4/1 power to both sides. Raise it to the reciprocal. So this just reduces, and you get 3x plus 1 equals 2 to the 4th. Well, 2 to the 4th is 16. So subtract 1, divide by 3, so you get x to the 5. Okay. If you look at the next one, you got the weird notation. So f of g of x means we're going to take g of x and plug it into x. So we have 4 times 3x minus 3 raised to the 2/3 power equals 36. So now I'm going to divide by 4 first. So I get 3x minus 3 to the 2/3. Right? 4 goes into 36 9 times. So now to get rid of the 2/3, raise it to the reciprocal, so 3/2. So this just gives you 3x minus 3, because this reduces to 1. So 9 to the 3/2 is asking you to take the square root of 9 3 times. But remember, you're taking the square root when you're solving, so this will be plus or minus 3 cubed. So you get 3x minus 3 equals plus or minus 27. So then we would just go about solving this. So 3x minus 3 equals 27. 3x minus 3 equals negative 27. And you just solve the linear equation. So add 3. 3x equals 30. Right, x equals 10. Add 3. Negative 24. So x equals negative 8. So when you're working on these, no matter if it's a square root or it's raised to some type of power, you want to isolate that part by itself so that you can square it or raise it to its reciprocal. So you can get rid of the radical or the grouping symbols. So now sometimes as you're solving these equations, right, the solution might work for the simplified version, but not the original problem. Remember, this is called an extraneous solution. An extraneous solution works for the simplified version, but not the original problem. So when we raise each side of the equation to a power, it's possible to introduce extraneous solutions. So we want to make sure we're checking our solutions. Okay. So example 3, solve and check for extraneous solutions. So I'm going to add 1 over. So this is x plus 1. So now you have the radical. I want to get rid of the radical. So what I'm going to do is I'm going to square both sides. On the left side, that's easy. The 3x plus 3 is all that's left, because the radical and the square reduce away. Now on the right side, you have x plus 1 squared. So this is a little different. Remember, that means you have an x plus 1 times x plus 1. So we're going to have to use the distributive property, FOIL it out. So x times x is x squared. X times 1 is 1x. 1 times x is 1x. 1 times 1 is 1. So remember, we're using FOIL. First, outer, inner, last. So this becomes x squared. X and x gives you 2x plus 1. Okay, so what stands out to me is there's an x squared. It's a quadratic. So remember, when we have quadratics, the easiest way for most of us is to solve it by factoring. So I want to get everything on one side, set equal to 0, and factor it. So I'm going to subtract the 3x right? So that gives me negative 1x. And then subtract the 3, gives me negative 2. So now I'm going to try to factor that. So 1 and 2, because those are only factors of 2. It's got to be a negative 1x. So minus 2 plus 1. So x equals negative 1. X equals 2. And we want to check our solutions. So we're going to plug them back into the radical to see if they actually work. Do they make our solutions true? So if you plug in 2, well, you get 2. Right? So this is 6, right? Plus 3. So square root of 9 minus 1 equals 2. 3 minus 1 equals 2. That works. Right? Plug in negative 1. 3 times negative 1 plus 3 minus 1 equals negative 1. So this gives you, right, negative 3 plus 3 is 0. So that one works as well. So both of those are solutions. Okay, example 4. So same idea. I'm going to subtract 3 first. Because if I have a radical or I have a power or some grouping symbols raised to power, I want that by itself so I can either square both sides or raise it to its reciprocal to get rid of the radical or grouping symbols. So now I'm going to square both sides to preserve the equality. So the left side, that's not hard, that's 5x equals 1. But on the right, that's x minus 3 times x minus 3. So I'm going to FOIL that out. So first is x times x, which is x squared. Outside would be minus 3x. Inside would be minus 3x. And then last would be positive 9. So x squared minus 3x, right? Combine like terms, minus 6x plus 9. So very similar to example 3. So now, right, I get rid of the radical, right? I FOIL out the binomial. Now I see I have a quadratic because it's x squared. So it's just like the last problem. I'm going to move everything over. So I'm going to subtract 5x. That would give me minus 11x. And I'm going to add 1. So that would give me plus 10. So now I'm going to factor. The plus 10 means they're going to be the same sign. So multiples of 10 that add to give you 11. That would be 10 and 1. Both a minus. So x equals 10. X equals 1. So if you plug those in to check to make sure they actually work. Right? So you plug in 10. You would get 50 minus 1. Plus 3 equals 10. So this is 7 plus 3 equals 10. So that works, right? 50 minus 1 is 49. Square root of 49 is 7. So 10 is the solution. All right, so if you plug in 1, right, you get 5 minus 1 plus 3 equals 1. So that gives you the square root of 4 plus 3 equals 1. Square root of 4 is 2. 2 plus 3 doesn't equal 1. So 1 is a solution for the quadratic, but not the original problem. So 1 is an example of an extraneous solution. So you got to be careful when you start raising things to powers on both sides. You sometimes create those solutions that work for the simplified form, but not the original problem. We dealt with this in our unit 4 before break. Okay, example 5, solve and check. So f of x minus g of x. So f of x is square root of 5x plus 1. And then we have minus 2 root x equals 1. So because this is f, this is g. So what I'm going to do is I'm going to move the 2 root x over to the other side. so that when I square both sides, I get rid of one of the radicals altogether. So this would be 5x plus 1. Now, the right side, there's nothing we can do about it. You're going to end up still with a radical, because you have to square 1 plus 2 root x. So this is 1 plus 2 root x times 1 plus 2 root x. So it's still going to use FOIL. So first terms, 1 times 1 is 1. Outside, this would give you plus 2 root x. Inside, plus 2 root x. And then outside. So this is a tricky one. So please make sure you're paying attention. 2 root x times 2 root x. 2 times 2 is 4. Root x times root x, right, is root x squared. But the square root and the square reduce, so you just get x. So one more time. 2 root x times 2 root x is 2 times 2 is 4. Root x times root x gives you root x squared. The square root and the square reduce, and all you have left is x. So that's 4x. So now I can combine like terms. So 5x plus 1 equals 1. 2 and 2 gives you 4 root x plus 4, because you have 2 and 2. That gives you 4 of them. Okay. So I see that there's a radical of x, so I know I eventually have to get rid of that. So I'm going to move everything over and then eventually square both sides again to get rid of the radical. So before I move everything, that's 5. So I have 5x plus 1 equals 5 plus 4 root x. So I'm going to subtract 5. So I get 5x minus 4 equals 4 root x. So from there, right, I'm going to square both sides. So this is 5x minus 4 times 5x minus 4 equals, now 4 root x squared, 4 times 4 is 16. Root x times root x is root x squared. They reduce and you get x. So now I've gotten rid of all the radicals. Still haven't solved for x, but I do start to see some daylight now because all the radicals are gone. So I'm going to multiply out the left side. And it's going to give me a quadratic that I'm going to try to factor. So 5x times 5x, 25x squared. 5x times 4 is minus 20x. And then we have negative 4 times 5 is minus 20x plus 16 equals 16x. So 25x squared minus 20x minus 20x. So 25x squared minus 40x plus 16 equals 16x. So I can subtract the 16x. So 25x squared minus 56x plus 16 equals 0. Then I can go through and factor that. So I can factor that, get it into its factored form. If I can't factor it, then I can do the quadratic formula. Right? So a couple of different ways I can try to approach this, depending on what you want to do. So again, if you want to factor it, right, that would probably be a good idea, right, to try to factor it. Right, so we're looking for the factors of 25 right? If it doesn't factor, then you can use the quadratic formula, right? So very challenging problem, right? I'm going to leave that last part up to you guys, but again, you can factor or do the quadratic formula to figure out your solution. Again, getting rid of the radicals, right? So by squaring both sides, I have up top the root 5x, right? I square both sides here where I'm underlining purple, right? We get 1 times 1 is 1, right? And then we have our 2 root x, and then from there, right, we can combine, subtract, square both sides, and then go about there from solving. So again, as you're working through the score words, this is a very challenging problem. We don't see too many like this. You'll see 1 or 2 of these on the worksheets. Please make sure to finish up your notes, right? You go through and write your summary, 3 to 5 sentences answering the essential question at top. When you're done with that, then you will be done with your notes. Have a great day.